Well, astrology has quite a bit to do with time. Astrology is a process of trying to predict the future, or predict what might happen by the positions of astronomical objects. So you could look at the positions of the planets in the sky relative to each other, or relative to the sun, or relative to the constellations. And so those objects, those planets and the sun and the moon, are going to be in front of certain constellations at particular times. And we know how to predict exactly when those planets are going to be in front of constellations, or when the sun is going to be in a particular part of the sky. So that clearly has a lot to do with time. Those predictions, however, may or may not have anything to do with our lives. Scientifically and astronomically, we can predict where these objects are going to be, or we can know when Jupiter is going to be close to Venus, for instance, so we can see a beautiful sight in the sky. Or we can predict when the planets will be in the right order through the solar system to send a spacecraft out to visit each of the planets in turn. This is the tricky one. I didn't have time to look up all my notes and remind myself. I have seen several different explanations. It involves some of the early methods of measuring time. There's some numerological effects in here as well. A number 12 is a nice number because it can be divided by 6, by 4, by 3, and by 2. So it has a lot of factors in it. It's a very useful number to work with. So astronomers in the Middle East in ancient times had this concept of 12 they were working with. And also the Egyptians divided the day into 12 divisions. They call them the decans, I think it was. A day and the night. So both of those were divided into 12, but they were 12 equally spaced periods, at least in the early stages. So you could call those the 12 hours of the day or 12 hours of the night, but each of those hours varied in length. It probably made more sense at some stage, certainly when we had some mechanical means of measuring the time, to equalise those hours. And so we ended up with 12 hours of the daytime, 12 hours of the night, 24 for the whole day, of equal length through the day. So you say that if the Earth's rotation period is less than 24 hours, why do the clocks stay in sync with the sun? Well, in fact, because we've defined time to make sure things stay in sync with the sun. So there are different ways of defining time and defining the unit of the second. We can define the second as being one small fraction of a whole rotation period of the Earth, from the time the sun is due north of a location all the way through until the sun is again due north of that location. And that we can say is 24 hours. And we divide that into a certain number of seconds. So by taking that definition for how long the Earth takes to rotate with respect to the sun, then we get 24 hours always. Even if the Earth over time is slowing down and the days are gradually, very gradually, over thousands of years getting longer, we can still define the day to be 24 hours long by the rotation of the Earth with respect to the sun. However, if we measure the length of a second by the modern definition, which is the vibrations of a cesium-133 atom, that unit of time, that second, is fixed. It doesn't vary like the second which we define from the rotation of the Earth. The second from the rotation of the Earth is gradually getting longer. The second we define from the cesium atom, the present standard, is fixed. So there is actually a divergence between these two measurements of time. Every couple of years or so, we need to add a leap second into the day to ensure that these two time systems, these two time standards, work well together. One of them is a purely mechanical way of looking at time. It's great for experimentation, great for the internet, great for industry, maybe the stock market, to keep in sync internationally or across cities. The other method, by measuring time against the sun, is actually very, very good for us as humans, because we measure our day by sunrise and midday and sunset, and we work and are active during the day and we sleep at night, most of us. So that's a good time system for humans to measure the passage of time, is by this measurement with respect to the sun. But the other technical definition from the cesium-133 atom is getting out of sync with ours. And the big question these days is, what do we do? Do we go with this technical definition, or do we stick with a human-based method of measuring time? No one's made up the decision about which way we'll go yet. There in fact is, yes. So timekeeping with clocks over the last few hundred years has relied on the rotation of the Earth to set the time. Every midday, when a telescope, a specially set up telescope, was looking due north, the sun would pass over the end of that telescope as the Earth rotated. And the interval between that passage of the sun across the telescope and the next passage of the sun across the telescope was 1 day. And we could also at night time observe the motion of the stars to measure time during the night. When we finally developed atomic clocks, time became dissociated from the rotation of the Earth. As people, as humans, we still use the rotation of the Earth in the day and night to measure our time. But technical time is dissociated from that natural rotation of the Earth clock. Yet, astronomy does still have a very important role to play in time, because we can measure time by the position of distant objects in space, and that allows us to measure the gradual slowing of the Earth on its axis as a result of the Moon's gravitational influence and the Sun's gravitational influence. So it's still very important that astronomy measure the position of distant objects, quasars and pulsars around the universe, so we can determine just how the Earth is slowing down, and in fact occasionally speeding up and changing in its orbit as the seasons come and go, as ice freezes on one hemisphere or one polar region or the other, and as earthquakes happen. The rotation of the Earth is always changing bit by bit, almost unnoticeable for us, but it is changing in a measurable way.